Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. Thank you for accepting our participation. I am Benhamou, PhD student from Northshire University Center. Our participation in the title of Comparative Study Energy Management of Hybrid Electric Vehicle based on NVDTC SVM controller. We have divided this presentation into 7 parts. We have introduction, dynamic electric vehicle system, hybrid power system and energy management strategies, NVDTC SVM controller, simulation results, energy management strategy comparison. Finally, is conclusion. Transportation is important in a human life. Electric vehicle is one of many transportation kinds. Our system is a two-wheel drive electric vehicle and induction motors. This motor is controlled by NVDTC SVM. This electric vehicle is connected with some sources, forming a hybrid system. These sources are fuel cell, battery, and supercapacitor. In this work, we are gonna apply some energy management strategies by using these sources to obtain the best strategy for our system. This is the electric vehicle. It has two-wheel drive connected with converters. Each converter controlled by NVDTC SVM. Proposed energy management strategies. The first figure shows the P strategy. It saves the state of charge of the battery and give us the reference battery power. After that, we obtained the power of the fuel cell. And the second figure shows the NV strategy. It receives the power of the electric vehicle and the state of charge of the battery to give the reference power of the fuel cell. In our system, we have three kinds of sources: fuel cell, battery, and supercapacitor. The motors of electric vehicles controlled by NVDTC SVM. We change speed controller by NV's controller. After modeling and simulation of the system, we obtain these results. On the right, the figure on the right is for electromagnetic torque of each motor, and the figure on the left for the wheel speed. We are seeing that they are identical, and the figure at the bottom is for the count of each motor. After the system simulation, we took these results of each energy management strategy. We are seeing that on the left is the P energy management strategy, and on the right is NV energy management strategy. We are seeing that there is a negligible overtaking in the voltage, and each one has the acceptance response time. So this is the power comparison. Each figure contains the fuel cell, battery, supercapacitor, and electric vehicle powers. We are seeing that the P strategy secures the charging of the battery at all times. of simulation, but the opposite in the NP strategy. It uses the battery in times and use the fuel cell in another time. This is the state of charge of each energy management strategy. We specify the 60.1% as initial state of charge of the battery in each strategy. We are saying the increasing of state of charge in P strategy because we specified 70% as the reference state of charge, but in the NP strategy we are seeing the balance of state of charge with respecting the object function. We are seeing the balance in NP energy management strategy and opposite in the PE strategy. We are seeing the directly increasing. So this is the air fuel cell consumption comparison. The consumption take the form of the fuel cell power. So this is the final result of taken from our simulation. The comparison between the statistical results of the performance criteria of the two energy management strategies of the electric vehicle system. The comparison points are reference time, overall efficiency, and state of charge, and fuel air consumption. The NFTs give us the best result compared with the PE controller. The specify the fuel and air consumption. And the overall efficiency it gives the best results and the best value 94%. In this work we propose the energy management strategies of electric vehicle two-wheel drive. We obtain that it can replace the PE controller by an intelligent controller from his acceptance results that we obtained. And the ANSYS energy management is better than PA strategy. Also from his and from its best result. Thank you for your attention, and we are ready to answer on your questions.